I have to cover in Docker, which is your Docker Swarm. Now, what is Docker Swarm? See, until now we have been working with one machine, right? Docker and everything we have installed on one single machine, and we are running all the containers on one single
Um,
machine.
Team, am I audible now?
Yes, you are. Welcome. So, yeah, so until now we have been working with one single machine, but
Hello.
hi Sedu, you're audible.
Sorry, there was some system settings. Sorry.
Yeah, yeah, that's fine, no problem. You're audible now. Yeah.
Yeah, thank you.
Yeah. So, yeah, so at any point, if you want to make your containers highly available, what I mean by that is if you want to run your containers across multiple machines, like, let's say you want to run five um, copies of Jenkins. Now, instead of running it on one single machine, you can run it across different machines. So basically, uh, multiple system architecture, we call that as a Docker Swarm or Docker services. So whenever I say Docker Swarm or Docker services, we are talking about multiple machines. Okay, your Docker would be set up on multiple machines, and then you will have your containers distributed across these multiple machines. So this concept of using multiple systems, we call that as a Docker Swarm or Docker services. So a Docker Swarm is a group of either physical or virtual machines that are running the Docker application and that have been configured to join together in a cluster. So, essentially you'll have more than one machine, and we call them as your cluster, right? So your containers will be running across these multiple machines. So your Docker Swarm is a container orchestration tool. So it's an orchestration tool, meaning it allows the user to manage multiple containers deployed across multiple host machines. So you'll have multiple containers which will be running across multiple machines. So Docker Swarm will consist of the below key components. You have the Swarm. So Swarm is basically your host, the machines. So consist of multiple Docker hosts which run in Swarm mode and acts as managers and workers. So you'll have one machine which will act as your manager, and the rest of the machines will be your worker machines. So within your Swarm, you'll have your nodes. So nodes are nothing but your servers. So an instance of the Docker engine participating in the Swarm, then you will have your services. What are services? Services are your containers. Okay, so the service is the definition of the tasks, the containers that you want to run on the manager machine or the worker machines. And then you'll have the task. So a task carries a Docker container and the commands to run inside the container. So generally, whenever we talk about your Docker Swarm, these are the components you will have. Now, this is how your architecture may look like. So you'll have the manager machines, you'll have multiple manager machines, and you'll have worker machines. Now, at any point, one worker machine can be part of one manager machine only. You cannot have one worker machine with multiple manager machines. So it's one-to-one mapping. So how do we work with this? So for this case, I'm going to launch one more server. So for the sake of example, we will be running two EC2 instances, and we will create a cluster. We will create a swarm between this. So one will be we will take one of the machine as the manager machine, and the other machine as the worker machine. Okay. Now you can have any number of worker machines, but just for sake of example, I'm going with one and one machine. So let's call this as Docker Manager, and we launch one more instance. Let's call it as Docker Worker. Right. So Ubuntu, then select our key pair, select our firewall, and the rest of the things are fine. What's happening? So this will be Docker worker and our key pair, my firewall, and then launch. So this will start launching the instance. Now we will have to install Docker on all the machines. Okay, any number of machines that you want to use as part of your cluster, you will have to install Docker on all those machines. Okay, so in my case, I will have to install Docker on the worker machine as well. So let's wait for the machine to come up. Okay, there's my machine. Let's quickly SSH to that machine. So sure. Search. This is the new server, the worker machine that I have. Let me update the machine. Then let me install. So apt install docker.io. That should install Docker. Okay, so that's the prerequisite. You have to make sure that you have Docker running on all the machines, right? Which are going to be part of your cluster, the swarm. So we have two machines. So this is the manager machine. So let me log into that as well. Now you'll have to decide. You can decide which one is going to be your manager machine and which one is going to be your worker machine. So in my case, this particular machine, you know what? Let's make it simpler. I can change this for me to easily understand. So I can use this set hyphen hostname CTL and then sorry, hostname CTL set hostname, and let's call it as manager. Now to reflect this, I'll have to exit and log into this server once again. So hostname CTL, that's basically a command line tool used to set your name, the hostname basically. Okay. So this will avoid some confusion for us. So that's the manager machine, and this is going to be the worker machine. So again, host name CTL set host name, and this will be the worker. So we'll exit and we'll log in once again. That should update the name, right? So we have the worker machine and then we have the manager machine. Now, once you're done with this, there are a few commands that you'll have to start executing. Okay, so the first you have to run is this command, docker swarm init. What this will do is this will initialize your swarm. So you are telling Docker that, hey, I want to use the swarm architecture here. So you are basically initializing that. Before I run that command, if you run this docker info command, you will see that the swarm, it is inactive, right? So that means we're not using this swarm as of now. So we'll run this docker swarm init. So this will initialize the swarm. It will activate the swarm for us, and it's done, right? So swarm initialized, current node is now a manager. To add a worker to this swarm, run this following command. So we need this command. So let me keep this aside for now. Okay, that's the command. And to add a manager to this swarm, you can run this. So you can have multiple managers as well. So I have the token. So this is the command that I need to run on the worker machine, right? And now if I run this docker info, you will see that my swarm is active. So you can see that's the node ID. And is this the manager? Yes. What's the cluster ID? how many managers we have, how many nodes we have, all that information will be available, right? Now, this swarm, it runs on port 2377. So you make sure in your firewall, the worker machines, the node machines, whatever you are using, in that firewall, you will have to allow that port number, which is 2377. Let me go to the firewall and let me edit this, and we will add my port. Allow this from anywhere. That's your network setting that we are doing here. Now, once you're done with that, you can take this command and run on your worker machine. So the machines which you want to be part of your manager, you have to run that command over there. So now you can see this node has joined a swarm as a worker. So really, this machine has joined a swarm as a worker machine. And here, if I run this Docker info, uh, you will see that the swarm is active. Node ID, is this the manager? No, right? So that means it has joined as a worker machine. So this is how you can add your machines to your Docker swarm. So now I have two machines and these are connected to each other. Questions?
So like we're not using any other networks, right? So I mean, like we use the some like I mean AWS for the networking, but like in the bridge, like I'm using bridge network or host network. Like there's another network called overlay network. Do we use that network also?
That comes in the picture only when we are running the containers.
Okay. Okay.
Okay, we are not yet running any containers, but in this case we will be using the overlay network because we have two different machines.
Okay.
We will utilize the overlay network to connect the containers with each other.
Okay. Got it.
Any other questions?
No, Ravi.
Cool. So this is basically how you can set up your swarm. Okay, the swarm architecture. Now you can run this Docker node ls command. So this will basically give you the nodes, what all nodes you have. So let me run this on the manager machine. So Docker node ls, and you can see I have two machines as of now, right? So this is the machine which is the manager machine. That's the leader, and that's the engine version we have. And this is the worker machine, right? And this is the version we have, the Docker engine version that we are running. So if you have multiple machines, it will show you everything over here. So Docker Swarm join, this is the command that we use to join the worker machines to the node machines, and Docker node ls is essentially what we can use. Now let's say we are going to create your containers. Now whenever we are creating multiple containers, we call it as your service. All right, so Docker service create, and how many containers you want, the name of the container and the image. So let me run this command here. So Docker service create hyphen replicas. I want, let's say, 5. Let's call this as Alpine container, and the image will be Alpine. So when I run this command, this will go ahead and create 5 containers for me. Task. Let me use a different one. Use engines. Am I audible to you guys?
Yes, Ravi.
Okay. I just want to make sure because it's not giving me anything. So let me see. So it's definitely not responding. It's fine. This is not working. So I don't know. Open up a different section. Seems to be some problem with the server. I'm gonna stop and stop it. That will not change. Okay, so let me stop and start this once again. Let's wait some time. Let me start that. So let me take that and so that is running. LS, that's also fine. This is also gone. So let me reconnect this. Okay, so now we'll do Docker service create. Let's say I want 5 containers. Okay, it's really up to you. You can specify whatever you want. Let's call this as Nginx container, and the image would be Nginx. So this will start creating the number you have specified. It will start creating that many containers for you. Now, because we have multi-system over here, what happens is these containers, they will get distributed across all your machines. Okay, so here, if I run this Docker PS, you see here I have 1, 2, only 2 containers. Okay, so you can see Nginx and then Nginx. This is a different container, right? So we can ignore that. So I have 1 and then 2. The other 3 containers are running on the worker machine. You can see that's 1, 2, and then 3. So you can see this number 1, 3, 4, and then I have 2 and then 5. So this is basically the concept of your Docker Swarm, running your containers across multiple machines. Does that make sense?
Yes, Ravi.
Now, how is this happening? In the backend, it is utilizing your overlay network. So what it has done here is it has created an overlay network for us. By default, so you can say this, it says Swarm. So always when we are working with your Swarm, it makes use of your overlay network to allow the communication between multiple machines. So this concept of running your containers across multiple machines, we call that as a Docker Swarm. So now here, if I run this Docker service ls, so you can see we created this container. So we created 2 services. The Alpine, it did not run due to some error, but the Nginx one, we had 5 replicas, so 5 out of 5 are running for us. You can also inspect if you want. You can see the additional details. So all these things can be done, right? So essentially, this is basically what the concept of your Docker Swarm is. So Docker Swarm is whenever you want to run your containers across multiple machines, we make use of your Docker Swarm for that. Questions?
No, Ravi.
Cool. So that's pretty much all I have as part of your Docker. Now, I'm not doing much on your Docker Swarm because in real time, you will not see people using this. You will see people using Kubernetes as part of your orchestration. Okay, so that is what we are going to look at next. Right. So Kubernetes is also very popular and very high in demand tool you have, and it's an ocean, to be honest with you. Okay, Kubernetes itself has so many things that you will have to learn. I would say you need a separate session for Kubernetes itself. It has so many things, but I'm going to cover the essential things. Okay, uh, few important things that you should be knowing as part of your Kubernetes. Only the basics things. I'm not going to go in depth with this. Okay. So Kubernetes is also an open source container orchestration tool, and this tool was developed by Google. Okay. So this was first released in 2015, July 21st, 2015. And this is one of the very active GitHub repo that you have. So this is open source, right? So anyone can come and contribute to this. So it's one of the very active repository that is available on GitHub in terms of commit. So continuously people are working on this. They are adding new features, improving the functionality, the performance, and everything. So features. So we have something known as pods. Pods here are your containers. So in Docker, we call them as containers. In Kubernetes, we call them as pods. You have replication controller, storage management, resource monitoring. You can do a health check of your containers, service discovery, networking. You can do a secret management. You can do a rolling update. So there are many features that your Kubernetes provides over Docker. Now, between Docker and Kubernetes, you will see people using Kubernetes as part of their container orchestration tool, and Docker is only utilized for building the images. All right, we don't run the containers using Docker. So Kubernetes is very high in demand. So that's the difference between your Docker Swarm and Kubernetes is that Your Docker Swarm is very easy and simple to set up. However, your Kubernetes is complex. Uh, there are a series of commands that you'll have to run in order to install Kubernetes on your machine. We will look at that. Docker Swarm is much faster when compared to Kubernetes, and your Kubernetes is much slower when compared to Docker Swarm. However, the main thing that ticks for Kubernetes is the features and the reliability. Docker Swarm is not really reliable for you, and it has very less features. Kubernetes is way more reliable, and comparatively, it has more features. So Kubernetes is feature rich. That's the main reason why people prefer Kubernetes over Docker Swarm. Okay, so this also follows your manager worker setup. So we call it as your master slave. So you'll have like one master machine, and then you can have multiple slave machines. Okay, so your containers and everything will be distributed across your slave machines, right? Now, when we talk about your Kubernetes, all right, so there are different components that are available on the master machine as well as your node machines. Okay, so at a high level, in your master node, these are the components you will have. So you'll have the etcd, API server, scheduler, controller manager, and then on the slave machines, you'll have the kubelet and you'll have the kubeproxy. Okay, so we'll talk in depth about these components. But generally, when we talk about the architecture, these are the components here. So on the master machine, you'll have the etcd, you'll have your API server, the scheduler, and the controller manager. And then on your node machines, you'll have the kubelet and you'll have the kubeproxy. Now, let's look at each of these one by one. So when we talk about your masters, it's a highly distributed key value source. So when you talk about your etcd, that's a component we have, right? So it's a highly distributed key value store, which is used to store the cluster wide secret. So all the secret information about your cluster will be stored in the etcd, and this is accessible only by the API server as it stores your sensitive information. Other components cannot access it. Only the API server can access the information from here simply because it contains our sensitive information. Then you have the API server. Now, API server is what um, we use to give the instructions to your Kubernetes as to what you want to do. You want to create a pod, you want to create a secret, you want to create a storage management, what you want to do. Those instructions we give by making use of your API server. So it exposes the Kubernetes API. The Kubernetes API is the front end for Kubernetes control plane and is used to deploy and execute all the operations and Kubernetes. So on the command line, when I run a command, these instruction goes to the API server, and then API server will get those instructions executed for us. Right? Then you have the scheduler. Now I told you that your Kubernetes, it follows your master slave architecture, right? Now this scheduler is responsible for scheduling your containers on the slave machines. Okay, so it takes care of all the scheduling of all the processes, the resource management, and everything on your cluster. So the scheduler takes care of scheduling of all the processes, dynamic resource management, and manages the present and future events on the cluster. So all the scheduling responsibility is taken care by the scheduler. Then you have the controller manager. Now, the controller manager runs all the controllers on the Kubernetes cluster. So you have your replication controller, node controllers. Likewise, you have different controllers. All these components are managed by your controller manager. Now, although each controller is a separate process, but to reduce the complexity, all the controllers are compiled into a single process. So you have the node controller, replication controller, endpoints controller, service accounts, token controllers. All these components are managed by your controller manager. So these are the different components we have. So once again, etcd is what all manages your secret information. API server exposes the Kubernetes API, so basically executes all the instructions. Scheduler is responsible for scheduling and managing the resources, and controller manager is responsible for the controllers like your node controller, replication controllers, and others. Questions?
No, Ravi.
Okay. And then you have the node machines, the slave machines. Now on the slave machines, we have two main components, which is a kubelet and the kube proxy. Now, I told you that the API server is the one that takes the instructions. Now, what this API server does is API server takes the instructions that we give, and then it goes to the kubelet, which is running on the slave machines, and it tells the kubelet that, hey, this is what you have to do. So those instructions, right? All those is executed by your kubelet. So kubelet takes the specifications from the API server. So it takes the instructions from the API server and ensures the application is running according to the specifications which were mentioned. So let's say I will run a command telling that, hey, create 5 pods for me. This instruction goes to the API server, and API server will pass these instructions to the kubelet. And then kubelet will create those 5 containers for me. So each of the node, let's say I have 10 nodes, each node will have its own kubelet service that will be running. And then you have the kube proxy. The kube proxy is your networking part. So this proxy service runs on each node and helps in making services available to the external host. So, if you want to access any application running on the container over the network, that's where your kube proxy comes in. So it helps in connection forwarding to the correct resources. It is also capable of doing primitive load balancing. So as a user, I'll go to the browser, I'll hit a URL, and it needs to give me that application. So that connection forwarding, the routing and everything is taken care by your kube proxy. So again, all of the node machine will have its own kube proxy service running. Questions?
No, Ravi.
So again, when we talk about your manager, the master machine, you'll have the etcd, API server, scheduler, controller manager. And when we talk about your worker machines, you'll have the kubelet and you have the kube proxy. Now talking about the setup. So again, before I start off with this, let me tell you your setup can be little complex. Okay, so there are numerous ways that you can install Kubernetes. Following are some of the ways. You can use kubeadm. So if you want to set up your cluster on physical machines or virtual machines anywhere, you can make use of your kubeadm. So kubeadm is a tool which can be used to set up your cluster. Then you have Minikube. The Minikube is used to create a single machine cluster. You can have only one machine. You cannot have more than one machines. Then you can go with your Minikube. Then you have COPS. So if you want to set up your Kubernetes cluster on AWS, you can make use of your COPS. And then you can also run Kubernetes on your Google Cloud. So AWS has its own service, EKS, which is an Elastic Kubernetes service. GCP has its own service. Azure has its own service. If you don't want to use that, you can set up your cluster manually by using any of these methods. So I'll show you how you can do it by using COPS. You can do it by using kubeadm also, but the problem I have with kubeadm is that it's not very stable. Okay, your cluster keeps failing. So I used to set up the cluster using kubeadm, but again, like I said, it's not really stable. It keeps failing. So that's where we are going to uh, look at your COPS. Okay, so here you should be able to find instructions. However, if you're still interested in setting up the cluster using kubeadm, here are the commands. So you'll have to run all these commands. And we are going to set up the cluster using COPS. So, this will be the instructions for setting up the cluster using COPS. Now, very important point I want to mention here is until now we have been using your T2.micro, right? The instance type. So this is free for us. Now the Kubernetes cluster will not work on this. The minimum we will need is T2.medium, and you'll have to pay money for that. So essentially, to set up the Kubernetes cluster, you will be charged. Okay. I won't be showing this today. I will show this in the next session on Monday. Okay, how you can set up the cluster, and then we will look at your other concepts as well. Cool.
Ravi.
Thanks, guys. I'll see
Ravi,
you.
I had one question. Ravi, actually, what is the difference between logs and events and in Docker? Even when we create any container, that was visible on the event. So how does it make any difference? Uh,
So, see, events are your real-time activity.
Okay.
As to starting a container, that's an event. Stopping a container, that's an event. Deleting a container, that's an event.
Okay.
Logs would be inside that container what you're doing.
Okay.
For example, let's say you start an application. Now you start accessing the application. That will generate logs.
Correct.
Right? So that's your logs. And events
Okay.
is at the container level. It is not inside the container.
Okay. Got it. Got it.
As to you create an image, that's an event. You create a network, that's an event. And logs
Okay.
would be your application. Anything that you do inside the container, that's your logs.
Okay. Got it. So another question, so when we create this virtual machine, right, we get an option to set the memory and all. So the application which is running inside the virtual machine, will it utilize the host memory or the virtual memory? I mean the virtual machine's memory.
See, it depends on either way, wherever you're running the container, whether it's on a physical machine or a virtual machine, the containers will utilize the machine's resources, whether it's a virtual machine or a physical machine.
No, actually, the question is that, for example, we set, for example, the physical machines of memories, let's say 8 GB, and then we set, while creating the virtual machine, we give the memory 2 GB or 4 GB, right? So the application which is running inside the virtual machine, will it be constrained to 4 GB, or it can exceed and then it start utilizing more than four, I mean the host memory.
No, that will not happen. It will it will utilize the memory on which machine it is running.
Okay, okay.
So if you're running it on the host machine, it will utilize the host machine resources.
Okay.
And if you're running it on the virtual machine, it will utilize the virtual machine resources. And whatever the resources you have, only that it can utilize. It cannot, uh, you know, uh, fail over to the host machine and utilize the resources. That is not possible.
Okay, okay. That was my question. Thanks, Ravi. Got it.
Okay. Yep. Cool. Thank you so much. And I'll see you guys on Monday.
Thanks, Ravi.
Thanks, guys. Bye.